in this video, we will solve a system of linear equation using Lu decomposition, specifically Kraut's method. We will solve the same problem as before. This 4 equations for a known problem. Okay. This time it's Lu decomposition. In general, the steps of Lu decomposition is this over here. Again, this is I got this from our reference from Amos Gilad ebook. It says here that remember our matrix is Ax equals B, right? In general. Now, that A matrix, this one, can be uh, transformed into an Lu matrix, lower triangular matrix and an upper triangular matrix. Now let's since A is equal to Lu, substitute A or Lu to our Ax equals B. That means Lux equals B. Okay. Now let's say that Ux is equal to Y, and then say here, so this one Ux is equal to Y, therefore Ly is equal to B. Okay, so here, so Lux equals B, but Ux is equal to Y, therefore Ly equals to B. Okay, so the Lu matrix is something like this. Therefore you have, since L is the lower triangular matrix, therefore the upper triangular matrix here is zeros, while the lower triangular matrix in U matrix is 0. This is more efficient, the Lu decomposition, compared to Gaussian and Gauss-Jordan elimination, because remember, if your matrix has a lot of 0, you're saving up memory in your computer. Okay, whereas the Gauss-Jordan and Gauss elimination, as you notice, it's an iterative procedure. Therefore, and zeros are not really present in all the matrix. Therefore, it consumes a lot more memory. Okay, unlike the Lu decomposition. Now, if we expand this, the L and U as equal to A matrix, you have this. Okay. Okay. So let's say A11, or sorry, let's say this one L11. This is corresponds to this. So A11 is equal to L11. Okay. While your A12 is equal to L11 U12. Okay. That's why U12 here is equal to A12 over L1 if you transpose L11. Therefore, while U13 is equal to A13 over L11. Okay, so I hope you get that. Now, there will be a procedure in doing this Lu decomposition. So step 1, we calculate the first column of L, wherein the formula is this. Step 2, as you notice, our U matrix has a diagonal of 1, right? The diagonal elements are all 1. Therefore, we substitute 1s in the diagonal of U. Step 3, we calculate the elements in the first row of U, except U11. Remember, U11 is already solved here as part of the diagonal. Okay, therefore the general formula for U will be U1j is equal to A1j over L11. Okay. Okay, and then for the rest of the elements, row after row, the general formula is this, or the compact formula. Therefore, to get the Lij, or the L matrix, Aij minus summation of k equals 1 to j minus 1 Lik Ukj. That is for j equals 2, 3 going to I, while for j equals I plus 1, I plus 2 going to n, your U matrix, sorry, your U, the element of U matrix or Uij is equal to Aij minus summation of Lik Ukj, wherein k is equal to 1 to j minus 1 over Lii. Now, these formulas will get you the L and U matrix, right? And once you get the L and U matrix, you will now have where's that? This, right? If you have the U matrix, you will now get the Y. Okay. Now, if you have the Y, then multiply that with the L matrix. Sorry. If you have the L matrix and B matrix is given, right, from here. So Ly is equal to B. Therefore, we will be getting the Y matrix. Now, once you have the Y matrix, you will now get the X or the unknown values, since you know already the U matrix and the Y matrix. Okay, so let's proceed with our sample problem. Here, where is our problem? It's the same problem we had since Gaussian elimination. Where's that? Here. So this is our problem before, for equations for unknown. So let's proceed with calculating the first column of L. So for I equals 1 to 1, 2 to n, our n is 4, right? So the formula is Li1 is equal to Ai1. So to expand that, I is 1. So L11 is equal to A11, right? So if this is 1, this is 1. So 1, 1. If this is 2, this is 2. So L21 is A21. L31, A31. L41 is A41. So what's our A11? It's 4. What's A21? Negative 6. A31 is 1. A41 is negative 12. Where is that? Remember, where's our A matrix? This is our, I'll write down. Okay, so remember, this is the A matrix, while this is the B matrix, right? So A11 is this, A21 second row first, that means second row first column, second row first, okay, first element or negative 6, third row first element is 1, fourth row first element is negative 1, negative 12. Okay, we're done with step 1. For step 2, substitute the ones in the diagonal view. So that's very easy. For we have I equal to 1, 2 to n. So Uii is simply 1. So if this is 1, this is 1. So U11, U22, U33, U44. Okay, so they are all 1. Okay, which is that one. So we're referring to this, the U11, U22, U33, U44. Okay, next, so this is becoming complicated. Step 3, calculate the elements in the first row. So we are going to find the first row elements except U11, because we already know that U11 is 1 from here, right? So let's rewrite the formula. U1j is equal to A1j over L11. Okay, so it says here, if this is 1, no, U1j, so j will be 2, 3, and 4. Okay, because we already know U11. So A12 is A12 over L11. Okay, U13 is A13 over L11. Okay, U14 is equal to A14 over L11. Okay, so we already know A12 as negative 2, L11 as 4. So U12 is equal to negative 5. matrix. Where is our A matrix so that you can see that? Okay. Okay, I'll copy this. This is our A matrix. Where's our A? There. Okay, I'll copy that. Copy. Then paste. Oops. Happened. Oops, oops, oops. Okay, so that's it. So our A12 is this one. First row, second element is -2, right? A13, first row, third element, -3 here. A14, first row, fourth element is 6. Okay? So therefore, we now have U12, U13, and U14. Okay? Oops. And which is this. Already know this. Okay. How about in the L matrix? We already know this first column here. Already know this at this stage. Okay. Next, calculate the rest of the elements row after row using this formula. Okay. So for I equals 2, 3 to n, and j is equal to 2, 3 going to I, the formula is this. Lij is equal to Aij minus summation of Lik Ukj, wherein k is equal to 1 to j minus 1. For example, for the second row, we're done with first row, right? For the second row, where that means I is equal to 2 because that is the second row. And starting from the 2, which I equals to 2, you have j 2 to 3. 2 to 4 rather, because your second row has second column, third column, and fourth column, right? Okay, so let's substitute that here. So Lij, so that means our I is 2, and then our j is 2. That means L22 is equal to, so whatever Aij, if this is L22, this is A22, right? So L22 is equal to A22 minus summation of L2, I is 2, 2K, UK2, because J is 2. Then our K is 1, 2, 2 minus 1. 2 minus 1 is simply 1, right? So therefore, our summation will be running from 1 to 1. Okay? So if I expand this, this Lij formula for second row, and j is equal to 2, this becomes this. A22 minus summation of L2k UK2. Okay, so further expand that, A22 minus L21 as our k, U1 as our k here, 2. Okay, then substitute the values. A22 is 7. If you refer here, okay, minus L21. Our L21 is second row, first element is this, -6. Okay, my times UK2. U12. Our U12 is this, -0.5. Okay, so operate that, you have 4. So our L22 is 4. So we now know this, L22 as 4. Okay, next. So after getting L, Lij or L22, it's now time to find U23 according here, because our I is 2, right? Second row. Our J now is 3. Okay. Okay. So U23 is equal to A23 minus summation of L2K. Where's that? L21 U13, because J is 3. Okay. Then our I is 2, so L22. Okay, that one. Then simply substitute the corresponding values from A matrix, the L matrix, and the U matrix. You'll be getting U23 is equal to 0.5. About U24? U24 is, okay, using this formula, U24 is equal to A24 minus summation of L21 U14 over L22. Okay, then get the values of this in our A, L, and U matrix. Substitute that, you will have U24 is equal to 0.75. Okay, so 0.5, so remember 4.5, 0.75, which is, where's that? Okay, that one. Oh, I'm sorry, move it here. 4.5, 0.75. So we're done with the second row. So next is the third row. Okay. Okay, where's that? Third row. So I copied again the formula so you can recall. Okay, for the third row, therefore I is now 3. Okay, then again, we have J equals 2, 3, and 4. Okay, so we have now I is equal to 3. So Li3, or sorry, L3. So L32, L33. Okay, then if this is 32, A is 32. Okay, A32 minus summation of L3K UK2. Okay, remember, as K here is 1 to J minus 1, but J is 2, therefore 2 minus 1 is 1. Okay, here our J here is 3, therefore 3 minus 1 is 2. Okay, that's why in L33, this summation here will now expand to 2 terms, unlike in L32, because your J is only 2, your summation here is only 1 term. Okay, so A32 minus L31 U12, L31 U12. Then simply get the values of this in the L and U matrix, substitute, then you will find it. Now for L33, L33, A33, so L33, A33, because I is 3, J is 3, I is 3, J is 3. So A33 minus summation of L3K, UK3. So your K will be running from 1 to 2. So L31, U13 plus L32, U23. Okay, then again, find the values of this in A, L, and U matrix. Substitute, you will have 3. So L32 is 8, L33 is 3. So L32 is 8, L33 is 3. Let's see that one. L32 is 8, L33 is 3. Okay, then let's find the corresponding U34. Okay, where's the U34? Here. Okay, U34, implementing this general formula, U34 wherein I is 3, J is 4. So A34 minus summation of L3K UK4. Since k here running from 1 to I minus 1. What's our I? 3, right? Because we're in the third row. So 3 minus 1 is 2. Therefore, it will be running from, sorry, from 1 to 2 only. So this should be 2. This will be 2. Okay, this will be 2. Okay. And then since that is 2, therefore this summation will have two terms. A34 minus L31 U14 plus L32 U24 over L33. Okay, and then again, get the values of this in A, L, and U matrix. Substitute, you will have U34 as negative 0.667, which is this. Okay, negative 0.667. Okay, so we're done with the U matrix. Now to find the other L matrix, so you just repeat the same process for the fourth row, and then you will come up with the complete U and L matrix. Okay, now we're done with LU matrix. Okay, you can check, no, you can verify that L and U, if you multiply these two, you will come up with the same A matrix. Okay, we can try that later on. Now once we're done with L and U, set up now the Ly equals B. Okay, so I set up the L, the Y equals B. So to solve the Y matrix, you use the forward substitution formula, which is this. This is very easy when you implement this in SMAT or even MathCAD. Okay, then once you get the of course this should not be X, no, I'm referring to the unknown, which is Y, but the concept is this, no? The formula is this. Okay, once you have now the Y matrix, you can now set up the UX equals Y. Okay, to solve this, you can use the box substitution formula, which has a general formula of this. Remember, we use this in what? Gauss elimination, right? The box substitution formula. Okay, so this, and implementing that in SMAT, so I can show you the implementation of that in SMAT. Where is that? Here. Okay, so I just copied the formula here. Okay, so this is the forward substitution formula, while this one is the back substitution formula as implemented in SMAT, and then I got the same answer of X. Okay, X equals 2, 4, negative 3.5. Okay, so in short, again, the beauty of having SMAT code like this, in theory, you can solve say 10 equations, 20 equations, 20 unknowns, using by just editing the A and B matrix, and just editing the indices here. You can solve in just a second the unknown X. Okay, okay. So that's the LU decomposition method as implemented in SMAT. Okay.